When the New Horizons spacecraft completed its flyby of Pluto in July of 2015, it revealed one of the most distinctive features of our solar system, a pale, smooth, heart-shaped plain roughly the length of Sweden. It's called Tombaugh Regio, named after the man who first discovered the dwarf planet back in 1930. But that's not necessarily the weirdest part of Pluto's geology. In fact, there are a bunch of weird structures, and this week in Nature Astronomy, astronomers may have figured out how some of the strangest features bordering the dwarf planet's heart came to be. The western half of Tombaugh Regio, called Sputnik Planitia, is a basically craterless giant field of ice, mostly in the form of frozen nitrogen, methane, and carbon dioxide. Scientists estimate it's less than 10 million years old, so on a cosmological scale, it's basically a newborn. Bordering this plain to the northwest, there are a couple mysterious landscape features. First, there are some level areas with repeated parallel ridges and troughs that can be tens of kilometers long. That's called washboard terrain, because washboards look similar, obviously. Then there's fluted terrain, ridges on sloped ground, either bulging out of a hill or mountain, or where a bunch of mountain peaks are connected to each other. And for some reason, all these ridges are pointing in the same direction. That configuration isn't matched by anything on Earth, so it's taken some effort to figure out exactly how they came to be. And now, after converting some of New Horizons images into topographical maps and analyzing them, the authors of the new study have some decent ideas. The team noted that in some instances, fluted ridges on mountain peaks transitioned into washboard ridges on the connecting valley floor. That suggests both terrain types are caused by the same geologic process. As for what that process is, here's the hypothesis. We already know that this region of Pluto is geologically active, with the crust moving and changing over time. Activity there would cause Pluto's water ice crust to break apart, and then bits of it would float on top of the denser nitrogen ice. Then, slowly, large nitrogen glaciers would flow to lower elevations, carrying the water ice debris with them. The researchers proposed that the ridges formed as that nitrogen ice sublimated, or changed directly from a solid into a gas, leaving behind the water ice. If they're right, it would explain why the ridges are more prevalent at lower elevations. Since the glaciers would flow downward towards Sputnik Planitia, more debris would end up there. And they aren't found elsewhere around Sputnik Planitia because those other places don't have the same type of geologic activity. The team was able to estimate the ages of these features by counting craters on the surface and got about 4 billion years. That's way, way older than Sputnik Planitia. But the researchers also acknowledged that there's a problem with this hypothesis. Even though the direction the glaciers moved would depend on their position relative to Pluto's heart, the direction these ridges are oriented doesn't depend on their position. So there are still some kinks to work out there. Either way, the team was able to conclude that we're looking at a totally new category of glacial landform, as if Pluto wasn't already unique enough. Speaking of far-flung worlds, astronomers also just announced that they'd found a possible super-Earth orbiting the closest solar star system to our own. You might have heard of Alpha Centauri, the 3-star system roughly 4.3 light-years away from the Sun, but less than 2 light-years beyond that, invisible to the naked eye, lies a red dwarf called Barnard star. As early as 1938, and especially in the 60s and 70s, Barnard star was thought to have at least one Jupiter-sized planet orbiting it, but the evidence for that wasn't great. And work published back in 2012 concluded there was nothing there, at least not within the detection capabilities of their equipment. But when the new team compiled a bunch of different data from different telescopes collected over the past 20 years, they found that there really does seem to be an exoplanet around Barnard star. If it exists, this planet would have a minimum mass of 3.2 times that of the Earth, orbiting its star about once every 233 Earth days. Given that Venus orbits our sun every 225 days, you might think that this exoplanet is super toasty. But Barnard star emits way less light than our own sun, so as close as it is, this planet only has an equilibrium temperature, that is, the temperature assuming no planetary atmosphere, of 105 Kelvin. For comparison, Earth's equilibrium temperature is 255 Kelvin, so it would be probably pretty cold over there. Again, there's still not enough data to confirm that this planet actually exists. It could be that the periodic signal that data is picking up is actually coming from the star itself, although that's unlikely based on the team's analysis. If there is a planet, it appears far enough away from Barnard's star in the night sky that we could use the next generation of telescopes to actually look at it, as in directly observe it. It wouldn't be the first exoplanet we've actually seen, but there aren't a ton of them, and this might be one of our first opportunities to discover the details of a smaller exoplanet's atmosphere. The recent demise of the Kepler Space Telescope, which discovered thousands of exoplanets, was a big blow to our search for planets around other stars. So research like this is a good reminder that there are plenty of other telescopes we can use, not to mention all the data from Kepler that hasn't been fully analyzed yet. When it comes to finding worlds outside of our solar system, we've barely brushed the tip of the iceberg. Thanks for watching this episode of SciShow Space News, and thank you especially to our community on Patreon. Your support allows us to keep making this show. We love that we get to talk about some of the weirdest and most exciting aspects of space research and exploration with people who love learning about the universe just as much as we do. If you're not yet a patron and you want to learn more about how you can contribute, just go on over to patreon.com/scishow.